Openstax College Physics, Chapter 2, number 46. So let me read the problem. I already drew the picture. I already have our menu equation right there. A swimmer bounces straight up from a diving board and falls feet first into the water. Boing, like that. Goes up, water. She starts with a velocity of 4 meters per second. I put that right there. Takeoff point is 1.8 meters above the water right there. So this distance to there is 1.8 meters. I keep losing my spot. How long are her feet in the air? What is her highest point above the board? And C, what is her velocity when her feet hit the water? So again, this is a kinematics problem, but it involves something new. It involves this G, this vertical motion with the acceleration for free falling objects. And I like to call it that. So let's just put over here, really important, G as 9.8 meters per second squared. Now we're going to learn later that G is what we call the gravitational field. I think it's important to call it the gravitational field. It's not the acceleration due to gravity, because later you'll see we'll still use that G and for things that aren't accelerating. However, if an object is only moving under the influence of gravity, no air resistance, no rockets, no magic flying stuff, then the vertical acceleration is G in the vertical direction. Actually, the vertical acceleration is negative G. Okay. Now, just be careful. When we write these kinematic equations, we put G as 9.8. So the acceleration is negative G. Okay. So our menu of kinematic equations is right here. We have the final position, the position at time t equals 0, the average velocity times the time, and it's really the change in time. Okay, it's just that other time is 0, so we don't put it in there. The final velocity at time equals 0, minus g, these are all for free fall cases, minus g times t. This is the most popular one, final position, initial velocity, initial time, or time, minus 1/2 gt squared. And then this one that doesn't have time in it, velocity squared, final velocity squared, initial velocity squared, minus 2g, change in y. So let's go back over here to this first problem. The diver jumps up, is moving up, goes up and comes back down and lands in the water. Okay. We want to find out what the time is to go from here to there. So we should go over here and say which of these equations have time in it and which ones have everything we need. So right up here, I can't use that one, right? I know I'm going to have to pick where y0 is 0, right? I need to pick where my axis is. So let's just go ahead and do that right now. Let's say down here, y is equal to 0. This is where we have y equals 0 at the water. Okay. So over here, I know my final y. I know my initial y. I don't know my time. I'm trying to solve for that. But I don't know the average velocity. I know the starting velocity, but I don't know the final velocity. Okay. Now, you may say the final velocity is 0. When we talk about this kind of motion, we are talking about the final velocity right before they hit the ground. Because once they hit the ground, there's another force. The acceleration is no longer negative g. Okay, so you can't use that one. This one, again, I don't know the final velocity. I can't use that one. This one I can use. Okay, I do know the final position. I do know the initial position. I know the initial velocity, and I know g. So let's just go ahead and use that one. So I'm going to put it right here, y0 plus v0t minus 1/2 g t squared. Let's go ahead and put in the values for everything that we know. I know my final y is 0. My initial y is 1.8, right? Because if that's 0, that's 1.8. My initial velocity is 4t minus 9.8 times 1/2 is 4.9. So minus 4.9 t squared. And again, we're right back where we were. We have the quadratic equation. So this is our a, b, and c term. So t is going to be negative b plus or minus the square root of b squared minus 4ac over 2a. So let's put in our numbers. We do get two solutions. Negative b is going to be negative 4 plus or minus the square root of 4 squared. Okay, now here we have 4. A is going to be negative 4.9, so we get that, and that's negative. And c is positive. So I'm going to get plus 4 times 4.9 times 1.8. All of that over 2 times a, which is going to be negative 9.8. So I want a positive time, right? So if I have a negative there and a negative there, I want the top to be negative overall. So let's just go ahead and calculate this thing in the square root right there, just to make it a little bit easier to see. So let's do that. Oops, sorry. I get 4 squared, which is 16. And then I have 4.9, 1.8. And then add that and take the square root. So this is 7.16. So if I say 7.16 plus this, I'm going to get a positive number on the top. And if I have a positive number on the top divided by a negative, I get a negative time. So I want to take the minus. So let's do this as minus 4 minus 7.16 over negative 9.8. And we plug that in. I get, I'm going to have to take that glasses off, 9.8 divided by, I get 1.14 seconds. So that's right here. And I put feet just so we know, 1.14 seconds. So we're moving right along here. Okay, next question says, how high did they go? Okay, that's a tough question right there. Because if we know how long it takes to go from here to there, do we know how long it takes to get here? And the answer is no, we don't, right? These are not even symmetrical things because she started up here and ended down there. So this is going to take less time than that. We don't even know what that is. What do we know up here? The one thing that we know is if you're at the highest point, you're going to be moving up, and then you're going to at some point be moving down. In the transition from moving up to moving down, you have to be at rest. So up here at the top, her velocity is 0. So I know my initial velocity, I know my final velocity. So we can use that to find the height. Which of those equations don't have time in there? It's that one. Okay, so we're going to use this equation. Now you could do this with average velocity too. There's a way you could do it, but I'm going to just use that equation. Okay, so I know final velocity squared is initial velocity squared minus 2g y minus y0. Now, what values do we know? We know a lot. Okay, we're trying to find for y, which is going from here to there. So let's say our final velocity is 0, our initial velocity is 4, minus 2 times 9.8 times our final y, which we don't know. My initial y, I do know, is 1.8. Okay, what does the question ask, actually? It says, what's our highest point above the board? Okay, so if we're going to be above the board, I'm going to redefine this as y equals 0, right? Because I'd have to find this distance and then subtract that distance, so might as well just call that 0. I know it's silly, but that's what I did. So now I'll have to solve for that. So I get 2 times 9.8 times y is 4 squared, which is 16. So y is going to be 16 divided by 2 times 9.8. I'm just going to write this as 8 divided by 9.8. Why did I do that? Because 16 divided by 2. I don't know why I did it. One less operation. Okay. So I get 9.8 divided by. I get 0.816 meters. And then part C says, I forgot already what it said, what's her velocity when she hits the water? Okay, so now I want to find the velocity down here. Going back over to my kinematics menu, here's my menu, which one of those have the final velocity that we can use? What about that one? That one looks like the easiest. Final velocity, initial velocity, acceleration, time. Now I'm going to use the time to go from here to there, which I have right there. So v final is the initial velocity 4 minus 9.8 times the time 1.14. That's it. Okay. Now we are going to get something cool here. So let's just plug this in. Sorry, I just can't see that stuff there. I needed like a big calculator. 4, 9.8, 1.14 times minus, I get negative 7.17 meters per second. So the negative means that she is moving down, right? She started off moving up. It didn't say that. Did it say that? It says she bounces straight up. Okay, so she's moving up with a velocity of 4 meters per second. So when she gets over here, she's going to be going down. You know, you could redo the problem and imagine that she starts off going that way at 4 meters per second. And then her highest point would be where she started. So, but it's set up, so that's that. Okay, again, start with your kinematics equation menu. So you can use to pick which one would work the best for what you're trying to do. The end.